Hey, Arc Junkies, welcome back to the show. Joining me this week is Aaron Pepper. Aaron is a Tig Welder at Boeing who welds titanium parts that are flight critical for F-15s and F-18s. In this episode, we discuss some of the nuances about welding titanium and how critical proper preparation and cleaning is when it comes to this exotic alloy. We also chat about the rigorous testing required to do the work that he does. We'll get right into the show after a quick word from our supporters. Today's episode of the Arc Junkies podcast is brought to you by Outlaw Leather. Are you looking for top quality handmade leather welding gear? Look no further than Outlaw Leather. Since 2017, Outlaw Leather has been crafting custom leather welding hoods, arm pads, bolt bags, sleever bar holders, and work belts right here in the U.S. in Pasadena, Texas. Each product is made by hand and comes with lifelong cleaning, a testament to their commitment to quality and customer satisfaction. Outlaw Leather is a family-owned business dedicated to supporting welders, welding students, and welding schools. I've personally been using an Outlaw hood for the past 7 years, and it still functions as perfectly as the day I bought it. Right now, listeners of the Arc Junkies podcast can get an exclusive 15% off on all in-stock handmade leather goods. Just use Arc Junkies in the discount box at checkout. Don't miss out on this fantastic deal. For custom orders, you can reach out to info@outlawleatherllc.com or visit outlawleather.com to place an order online. And don't forget to give them a follow on Instagram @outlawleather for the latest updates. Outlaw Leather, quality you can trust, made by hand in the USA. We're also brought to you by SendCutSend, one of the most innovative services in the industry. Attention, welders, fabricators, and makers. If you need custom parts quickly and affordably, look no further than SendCutSend. Since 2019, SendCutSend has been changing the industry with their CNC laser cutting, water jetting, CNC bending, powder coating, anodizing, zinc coating, nickel plating, hardware insertion, and tapping services. They offer a wide array of materials including metals, woods, plastics, and composites, and often ship within 1 to 2 days of receiving your order. Ordering from SendCutSend is not only cheaper than purchasing and maintaining your own equipment, but also incredibly easy. Just draw up what you need, upload it to their website, select your custom finishings and machining options, and they'll ship the parts right to your door. No access to CAD software? No problem. SendCutSend has you covered with several designs and templates right on their website, or you can work with their design team. Visit SendCutSend.com to upload your drawings and get started today. Follow them on Instagram @SendCutSend for their latest updates. SendCutSend, innovation and custom parts delivered fast. All right, you know what time it is. Fire up your machine, drop your hood, and turn me up 5.
Thank you for downloading show number 232 of the Arc Junkies Podcast.
You're listening to the Arc Junkies Podcast, helping you make every weld better than your last with each episode. And now your host, Jason Becker.
All right, Aaron, welcome to the Arc Junkies podcast, man. Thanks for coming out.
Hey, man. Thanks for having me.
Yeah. So aerospace is one area that I really haven't had too many guests on when it comes to aerospace. It's one of the sectors of the industry that I don't really know a whole lot about. So when you reached out and you're like, hey, man, I'm an aerospace welder, I'd love to chat. I was like, oh, this is perfect because it's an area that I really don't get to talk to many people in. I think Chloe Hudson's done a little bit of aerospace and some nuke work. But aside from that, I don't know too many people that are in aerospace. I have sent a few students to Piper Aircraft, so they make like Learjets and all kinds of different, personal aircrafts and stuff like that. But I mean, they're all students that just graduated school. But I really don't know a whole lot of about the industry of aerospace. So I'm really looking forward to this chat.
No, I have a lot of, fortunately, good things to say about it for anybody who's interested in aerospace.
Now, how did you get involved with aerospace? Did you originally go to school and learn welding and then kind of branch out and get into aerospace? Or like, what was that? What was your journey like?
I originally went locally to best, I guess. I mean, a trade school is a trade school. It depends on your instructor at that specific school. But kind of the one to get into that has probably the most funding. So, you're going to get nice machines and a lot of material is a school called Rankin Technical College in the St. Louis area. So I went up there for automotive and I learned pretty quick that, I really started thinking about it. I don't want to end up working on Not that anything's wrong with it. It's just not what I wanted to do for a job. I don't want to work on somebody's exhaust at Midas or, replace transmissions all day. It's fun in your garage, but probably not to do every day for a job. And in going there to look at automotive, I saw welding. And then at this time, I might have thought welding, I think, was what you saw on TV. I mean, where they just kind of usually have a blowtorch and it just is a catch-all for all welding scenes.
Right.
And they're not even pointing it at anything. So I didn't even know that welding had to do with electricity, to be honest. I mean, there was no trade background with my father or really in my family, to be honest. So I just kept looking over there at them doing that. And then it piqued my interest enough that I ended up going there to do that instead of automotive altogether. And that's kind of how I started. They had just got set up with all new ESOB machines in 2011, I think, is whenever I went there. And we kind of did the standard MIG, stick, TIG type deal. Just your plate, some pipe. I got out of there and then went to probably what you would call an entry-level welding position, just running stick out on these barges up and down the Mississippi right here in St. Louis. The pay wasn't really what you think. As soon as you're able to weld, I wasn't really able to weld. I mean, I had an idea of how to weld and I could weld decent for somebody who just walked out of school, but you're thinking you're going to walk out and you're going to make what everybody says you're going to make, what a pipeliner makes or something. And it wasn't happening. So I'm trying to figure out where am I going wrong? And then slowly over the years, I went from welding outside on those barges after school to small job shops, stuff like that. I finally ended up about 2014. So a couple of years now bouncing around from different job shops locally and different kind of like small contracts or tradesman stuff. I ended up at a place that makes industrial HVAC units. And I did some aluminum tread plate with a spool gun, which I lied and said that I knew what to do with that. I went home and I think I watched Welding Tips and Tricks immediately. And then I did pretty decent. with the spool gun. We did a lot of thinner wall angle, maybe like 1/8 type, just mild steel angle as far as MIG goes. Did some thicker mild steel and a little bit of carbon, flux core and TIG, and then did some stainless as well. Probably for 7 years or so, I really cut my teeth on basic welding in every process. So we didn't really have any certs besides just in-house, no process spec or no WPS that we were working to, no procedure really of any kind. Everybody just walked around and said they were certified as soon as you passed their in-house little uphill flux core deal. So I even was saying I was certified. I mean, it's just, they threw it around so loosely that whenever I went into aerospace after about 7 years doing that in the HVAC position, I just thought it was a quick test. They were going to see me weld. I never put my hands in a chamber. This was about 2021 when I left that HVAC position. 2021, I went and just on the limb decided I'm going to try to do this welding stuff for a company called GKN, who just recently got bought out by Boeing, which is how I ended up with them. I put my hands in a chamber when I showed up there, thinking I'm certified, been welding all these different processes for a long time. They wanted the machine set on a certain way. We have a weld schedule, and it tells you, it's what you're going to certify to. It's their process spec, and it's obviously taken from D17 with a few of Boeing's different, specific, the material, titanium, 6AL4V, stuff like that added into it. It's just a world that I didn't see. It just is overwhelming. I never welded in a bubble before, so I wasn't used to having my arms in this thing. I wasn't used to following correct procedures and actually documenting what I'm welding. So that was kind of a fake it till you make it thing. I showed up there, thought I was way better than I was, and I really wasn't. But I did good enough to stay on, and then I ended up getting all my certs. And that's kind of where I've been ever since.
Now, they had you welding on titanium inside that purge tank?
Yeah, I also, and I don't recommend this, but it worked for me. I said that I was familiar with titanium, again, I never said I welded it. I said I was familiar with titanium. And I remember and this probably is how I got the job. I was just good enough because they're not obviously going to test you and send out and x-ray and etch and do all that. They're just trying to see, can you feasibly do anything we're asking you to do? So whenever they got that setup in there, I remembered Jody on Welding Tips and Tricks said that it's a real sticky process. So I just had that in mind, and that saved my life, I think, and got me that job, because it's really no different from TIG welding anything, which I had general experience in. I was by no means a ace TIG welder at the time, but I could run a good bead, vertical or horizontal. It was 2G that they set it up in. And the only thing different was it was real sticky. And I wouldn't have known that had I not watched some YouTube videos on it beforehand. So when I was pulling that rod back out of the puddle, where usually you seem to kind of be able to let it lay in there, I was really having to pull this thing back out and then progress my bead. So I don't know. It just, TIG welding has come pretty natural to me. It's been pretty, I really like the process and I understand the puddle pretty well. But no, I'll say learning that it's a real sticky puddle and what that meant, kind of handle it kind of like gum, was the only change that I made. And it made for a really decent first weld on titanium ever. They didn't know I never touched titanium. They took I'm familiar with it as I welded it and I didn't correct them.
No, that's pretty neat. I got to weld probably about 2, maybe 3 inches of titanium one time with my buddy Bingo Welds. We did that Ink to Bay thing, and Travis Fields and Wally's Welding World was out there, and so we were all back there messing around with it, and it's definitely sticky. And then the filler metal's got like a matte finish. You would think titanium would be super shiny, but it's got like this matte finish on it almost. And the whole process is a little bit weird. It's kind of similar to stainless, but it kind of reacts and welds different because, like you were saying, the puddle's a little bit sticky. It's almost, I want to equate it to, it kind of flows like Inconel, to where it's like, it's muddy. That puddle doesn't want to work itself down the joint. Whereas with stainless, it's all nice and clean. It kind of flows. It's very fluid. Inconel or titanium rather, not so much.
Yeah. Well, if you, so we have, again, I can't probably go into specifically where it lays on the plane. The parts that I'm primarily making or that I'm building, they end up on the F-15, some on the F-18, but primarily the F-15. And there's commercial pure titanium that we use, which is commercially pure. It's just pure titanium. Then there's 6AL4V. And I'm not going to lie and say I know exactly the makeup, but I know there's significantly more amount of aluminum in there, which I think makes for that kind of mud feeling that you're talking about as far as 6AL4V titanium goes. They both weld kind of, I'm trying to figure out a way to make it not sound that bad, but you're kind of right. It is a little bit like Inconel, and it is just a kind of sticky, muddy weld, but we weld in a chamber, so there's no worry about trailing shields or adequate coverage. Everything's covered, so you can kind of get into a position that suits you best and just go to town on it and not worry about making sure you're not at a weird angle blowing that gas away.
Now, because you're in a chamber, because I've never welded with a chamber. I don't even think I've seen it done. I've seen them, but I've never seen anybody weld in a chamber. Do you have to use a cup on the end of your TIG torch at all? Because it's a completely inert environment? I do, because I walk a lot, but you got to be real careful because you can't have those marks on there. But I kind of walk and I wedge a lot in spots. Okay.
But no, there's times where you can't have you might be able to have a cup, but I'll just get brand new tungsten. I'll sharpen that tungsten and then I'll put it in there with no cup. And then I'll shove it all the way in, because a lot of the stuff we're welding, 90% of it's in a fixture that was made for that specific part. And the fixture has copper in the correct spots. A lot of times it's a mechanical fixture. It'll tighten. It's not just a fixture you clamp down. It's something that you can screw and it'll tighten to the part, that copper. So you're really not able to keep the cup on there in a lot of spots, but it almost messes with me. Even after years now, it messes with me when I don't have the cup on. So I usually I'll leave the cup on there, but you definitely can take the cup off if you want.
That's kind of what I was thinking, like, because you wouldn't even need shielding gas at that point, because the whole bubble is just completely purged.
There's no need for gas lens or anything going on with what your cup size is, or, you're not. Sometimes I will use a glass cup because I will want to see in there and I want to rest the cup on something, or a Pyrex, I guess, but there's really no need at all for any kind of cup diffuser or anything like that.
Now, what kind of weld joints are you typically running? Does it kind of range? You do some butt joints and some fillet welds, and
it's
or
butt
like a
joints,
mix?
fillet welds. There's outside corner. We certify and we weld all these. This is where the range is kind of what Boeing put in there, because that's the stuff that we're welding on there, on top of the general D17-1 certification and all the testing. I brought actually all the process specs so I could look at it and then not completely forget whatever I was saying. Or I'm sorry, not the process specs, but the visual inspection reports and the metallurgy reports and all these tests, that the performance qualification test record. So the testing is a butt joint at 20 thousandths, and then a butt joint at 1/4 inch. And then we'll do that vertical, and then we'll do that horizontal, both size ranges, each direction. And then we do a T joint, and we don't do a thick T joint. We just do the 20 thousandths T joint. So at the end of everything, there's 5 tests that we send out to have x-rayed and cut up. And that really kind of encompasses all the welds we end up doing in the chamber. We do some pipe. Well, I wouldn't call it pipe. It's not pipe. We do some tube, but that falls under their butt weld. So we got certified under that. There was no specific pipe or tube test that we took to do that. So yeah, mainly it's butt welds, different configurations. You can't always spin these fixtures the way you want them in the chamber. So, you have to kind of go upside down, stick that tungsten all the way out, get in there and do some of that stuff. A lot of vertical, mainly butt welds, and probably outside corners.
Okay. Now, when you do this, are you running like a standard collet body, because that kind of, it's a little bit less mass than a gas lens at the end, because you're not running a cup, so it really doesn't matter because you don't need it for the benefit of shielding gas.
I do. I'll run like an 8, just because that's what I was always. We did a lot of steam pipe when I was doing that industrial HVAC work. And when I say HVAC, if I jump back to that, it was industrial HVAC units. I wasn't actually installing or having any knowledge at any time about HVAC stuff. People hear HVAC and then they want to talk about stuff, and I go, I was just building these giant HVAC units.
Right.
And by building it, welding the frame, which was the flux core, because they crane these on top of buildings, and then pipe welding when it came to the stainless and some of the carbon stuff, usually schedule 40, some schedule 80. That's whenever I was really tuning in my TIG welding, I guess. And I had just gotten so used to having that cup on there that I just keep the cup on in the chamber. But no, a lot of the guys, they prefer no gas lens in there. If they do have a cup, they'll get just, that old school collet body, the old school setup, and that keeps it a lot thinner and less bulky. And then other guys, and I'm saying other guys, there's only 3 of us. The other guy, he just never really puts a cup on the end of it at all. It's just bare tungsten sticking out all the time.
Now, how far do you run that tungsten out of the torch?
You can run it all the way out. Just put it in enough for that cap to catch,
for it to grip,
and tighten down on it, and you can have it as long as the tungsten is probably minus, a 1/4 inch or something, to get it in there and just barely get it tightened down. But you can stick it all the way out if you need to, and sometimes you have to. It's just it depends on where it is. There's different size chambers for different fixtures and different weldments. So some of those chambers, where if you're out in the open, you can lean over, you can use your knee to push down the pedal, you can do different things and get it as close to you as possible. Once you put your arms in this chamber, you can't go any, further than the glass, the shade lens, and then, there's just a bulky kind of like door right there. So you can't push down any further. You'll be smashing your nose up against the lens and the glass and trying to get in there, but you just can't push your head far enough as you would like to sometimes. So you have to stick that tungsten way out.
Yeah, because you're not using a hood, right? I mean, they've got like a lens right on top of the, or I would imagine like a tinted cover on top of it.
Yeah, I just stopped flicking my head down probably a year ago. There's a lens on top of the glass, and we can slide it. There's no hood that you're traditionally wearing. I will do some stuff if maintenance asks us as like a favor to weld something. Then I'll use one of the kind of freestanding welders, and I'll go weld it, and then I'll put the hood back on, and it'll feel like I'm actually going to work. But there's no hood. I sit in an office chair, and we put our arms in, and passing all the tests, the 10 total tests, and waiting for those x-rays and all that stuff. After you get all that stuff taken care of and you're fairly confident and you're understanding what, you kind of need to do with each situation, it's really probably the best welding job I've ever had. I can't imagine if you're the type that wants to hang off the side of a skyscraper and, do some iron worker stuff, then I would not recommend aerospace, because it's a lot of sitting in an office chair and welding real clean OEM stuff. We don't really do any repairs. It's all OEM parts.
Yeah, so I was going to ask, what's the cleaning process look like? Because I know with titanium, it's got to be super clean. I remember I did a video with Jeff Ray when I was with weld.com, and he does he was doing exhaust systems for ballistic cycles, and it was all titanium exhaust systems. And he's like, man, you can't even touch this stuff with a bare hand because it'll leave the oils on there forever. And then you got to like buff them out and all that stuff.
Yeah, so there's two different types of cleaning. It's in the procedure qualifications and all the paperwork we're doing leading up to the testing. Everything, the test material is called out to be pickled, because all the stuff that we're welding, all the parts we're welding in production, they're all pickled. So there is that matte film you're talking about, but I actually have not run into that too much, because everything's pickled. It's dropped down in there, and so many thousands is kind of peeled away. It's just like ultimate cleaning versus any wire brush or anything like that. So every part we get is just as clean as it's possibly going to be. We don't clean it. We'll wipe it down with acetone or something if it's been sitting for a minute, but usually it's as clean as it's going to get. And we wear white cloth gloves to touch everything, and then you just throw them out anytime you touch something else, which is all the time. So you touch the chamber door handle to open it, you got to throw your glove away before you start touching the part, before you start touching all the filler material, all that stuff. The cleaning process for the actual parts really isn't much more than just a little wipe with acetone on occasion. They're already pickled and completely clean. Welding on the test, before we send in all the tests that are going to be x-rayed, and they're going to start etching them and doing all that stuff, cutting them up and really coming after us, we'll scrape the titanium. There's no grinding or anything like that. We don't even bevel any of the 1/4-inch test plates. Those are all machined down the hill. So they're pickled and machined, and those come relatively clean, but we still will scrape that top layer off of it. I don't know what that film is when it starts swirling in there. It's not really like a mill scale. It's not, I guess it might be like an oxide layer, but it doesn't even, I'm not confident that's what it is scientifically. It's just a real thin coating on that titanium that makes it kind of matte. And as soon as you take that off, it welds a lot smoother than what you're talking about, that kind of muddiness in there.
Mm-hmm.
My experience anyway. It could be how I'm welding it or how I'm operating things.
Now, you said you scrape it. What do you scrape it with? Like a razor blade, or you got like a specific tool for that?
No, we have a specific scraper, like a tool steel hardened. Kind of looks like a little chip. Like you might start chipping away with it, but it's a hardened steel scraper, and you just ever so slightly scrape the top part of that titanium. You don't want to take away any thickness. You just want to scrape that top layer, that matte layer off that you were talking about.
Okay.
But again, that's only the cleaning for the, preparing our test joints. The actual parts, we're not cleaning them. They've already been machined and pickled, and they're already clean and good to go.
Very cool. So, I mean, like, you don't have to worry about any of that stuff. You just grab the parts and you slap it into the fixture and clamp it all down and start welding on it.
We have fitters that fit it all up and roll it over to us, and then we roll it into our chamber.
Now, how big is this chamber?
My chamber that I primarily use with my desk in my area, my my little bat cave is probably 3 feet, probably 3 feet deep, 3 feet tall, 3 feet wide. So, but it's angled where that glass is. It's not just a straight, 90-degree glass. It's like an angled chamber right there. But it's not too big. There's a much bigger chamber for a long pipe assembly that we weld. I'll go to that spot if I have to weld those pipe. But my primary chamber is probably about 3 feet wide, 3 feet deep.
Okay. So, I mean, the parts are relatively somewhat small.
Yeah, none of these parts are, I'm trying to think. There's not one part, and it's titanium, so it's really light. There's not one part that you can't just pick up and kind of walk to wherever you need to.
I was going to say your fixture is probably heavier than the material you're welding on because titanium's like super light.
These fixtures we have tables where we crank the fixture up to the level of the chamber because everybody's chamber, the other two guys, their chambers are different height than mine. So we have kind of these tables that all the fixtures are on, and it's solely, people think, like engineers or people, managers, they'll think that the whole part is encompassed on top of the table. And whenever they find out that the part's not even on there, that's just the fixture. We haven't even got the part on the table yet. They're like, well, that's a little bit big, isn't it? I'm like, the part's not even on there yet. So yeah, majority of what goes in the chamber is the fixture. And they spend a lot of time getting these fixturing correctly for what we're doing, which has not ever been the case anywhere I've ever been. You've had to come up with your own random in-house fixture that you just put together to help you out at that moment for the most part, if you even get the time to do that. But yeah, these fixtures are pretty complex. It'll be a lot of machined copper, a lot of screws, a lot of fasteners, a lot of different mechanisms to get this part on here and secure perfect, and then be able to tighten the fixture outside against the part. Then a lot of times there'll be a secondary fixture that goes with it that the fitter will slide over, and then that will just tighten everything down even more, trying to control distortion, all that stuff. The testing, the die pin, to get it stamped off whenever they start measuring it, making sure that all the thicknesses are correct, everything's within tolerance, everything's, what the process spec is calling for. That's a big deal. The paperwork is probably 50% of the day in aerospace, whether you're welding or, taking out the trash. Everything is procedure. What process spec are you following? You can't be caught. I think the scariest thing is if somebody walks up and they ask, well, where'd you get that? Or what process spec are you following, to reach the conclusion you just reached? What is this all about? And you shrug or you say, I don't know. Theoretically, the process you're following is supposed to be.
So everything's got to be spot on according to that procedure that you have.
Yeah, everything is right there next to the booth. Pretty much all the same way whenever you're qualifying and you're taking your weld test. What range was there as far as amps are concerned, what filler material, all the heat lot numbers, all the stuff. All that is every time you weld a production part, you're filling it out with the heat lot numbers. You're filling it out what range you were in, what process spec you followed, all that stuff.
Oh, so you're actually documenting that you welded it to the procedure. You're not just looking at the procedure, setting your machine, and doing all that stuff. You're actually documenting as you go.
Yeah, every part that we weld, the procedure that we followed is in there, in the paperwork that follows that part. And from my understanding, it follows the plane until 10 years after the plane isn't flying anymore, too. So even if nothing happened with it, and it was fine. When that plane's out of commission, that paperwork's still with it for 10 years.
That makes sense.
They follow that the whole length.
Yeah. So that's one of the very few industries, or one of the few people that I've had on my podcast that actually follows or is given a WPS, expected to follow the WPS, and then you've got documentation that you have to do on top of that to make sure you're in compliant, you did everything correct, so it stays with the life cycle of that aircraft.
Yeah, that was, like I said, that was along with flicking my head down when I don't have a hood on for a long time. That was a big learning curve, was documenting every ounce of what I was working on. We had an audit, an ADCAP audit, at the beginning of June, and it went really well, but, he'd ask he was asking the angle of my torch. You're kind of sticking that thing way up there. Is that, what kind of degree are you doing? Is the machine calibrated? Where is it telling you to fit this up there like that? Are you allowed to have this gap that's in there? And then you'd have to keep referring them to the process spec, and then the process spec would call out the specific weld procedure, and then you'd have to pull all that stuff up.
That's good. They've got all that documentation and, due diligence along with it. Are these, I would imagine these parts are flight critical to some extent?
Yeah, anything that's going to leave the ground, even if it's a spot weld, if you go to a spot welder and a quick spot weld, there's no actual manual welding of any kind. Anybody can go over there and hit that pedal and spot weld that part real fast. If it's going to leave the ground, you have to follow all the same testing criteria and be certified the same way. So, yeah, everything that leaves the ground is following the same procedure.
Now, do you have to recertify throughout the year, or is it like you've got continuity because you're continuously involved in this work year round?
I believe it should be 5 years, but Boeing makes us do it every 2. We should be able to show that we're doing everything the same way, following everything correctly. It used to be 5 years before I started, but staying on top of quality and stuff like that, I think they found it better to make sure it's 2. So we have to go, do whatever Jaeger eye test every year. That's not every 2 years. That's every year. Then the actual weld tests themselves, all of them for stainless 321 and 6A04V titanium, all those are every 2 years. The full beginning to end tests on all of them. So it's like a month process just to test everything every 2 years.
Oh, damn. That's kind of cool. You get, you get to go test for a month, and you're working, but you're not really working. You're just in there welding parts out. Yeah.
The only one that you're ready to cry is that first one to get to stay working there. Once you've already passed it all, if they know it's going to take you a month, because you got to do those tests that I told you about, the 20 thousandths, the 1/4 inch. You have to do those for the titanium, and you have to do those for the stainless, because we also weld 321 stainless. So all in all, with the 2 T's, the 2 thick butt joints, vertical and horizontal, and the 2 thin ones, it's 10 tests that we send out. And if you pass all of them on the stainless side, besides one, you can't, they all have to be passed. So, and your certification starts the first one that they test and pass, but you're not certified. Like, your date starts on that day, but if it takes you, because the T is the hard one, if it takes you a month past passing those butt welds to do the T, well, you just burned a month, because they put you in the system the second that you pass a test, but you have to pass all 5 of them, if that makes sense.
Yeah. So now you got a year and 11 months before you get a retest.
Yeah. So it's in your best interest to get all those tests passed. Usually the butt welds you send them out the first time. Titanium's tricky, but once you've done it a little bit, you got a couple months of testing in there and really getting it, you can usually pass those butt welds on the first try. Not to take away how difficult they are in the moment, but those T's, that's where you're just kind of sweating, waiting for them to send back the x-rays and the etches. Or, well, actually on the T's, they don't x-ray them. They just cut and etch them and do all that. But those ones are hectic.
Yeah. Now, you were saying the tests are pretty much 20 thou and then up to 1/4 inch. Now, when you're in production,
yeah.
Is it pretty much those two thicknesses, or do you have a range of material thicknesses like most WPSs or welder performance quals? They give you twice the thickness?
No, it's your max thickness that you tested is the max thickness that you're allowed to weld out there. The high end and the low end. The 20,000 is really rare. It's usually in between 30 and 40 on the low end, production wise. But there are situations, because sometimes the way things are machined or the way they're fit up, the whole part will be 30,000s, but there'll be one little sliver that's 20,000. So the test has to be taken at 20,000s.
Makes sense.
Even though you will run into that, once every 2 months, you'll run into that little 20,000 section. Everything else will be in between 30 or 40,000s up to, quarter inch usually. Rarely a quarter inch, but again, some parts, once you put this on there and then you weld this and then they add the fixture and then they add the other, because we're making parts, giving it back to the fitter, they're adding stuff, adding a new part. By the end of it, you could have something that's about a quarter inch that you have to weld, but you're usually not grabbing just a quarter inch piece of titanium off the shelf and welding it.
Okay. Now, with your purge system, is there some sort of like purity monitor to where, you've got like a instant feedback if you don't have 100% pure argon on it in there, if oxygen's being pulled in from the atmosphere or nitrogen or anything like that? Do you have like a little meter that's going to let you know that, hey, something's not right, you need to, check your purge?
No, that's something that I've been asking for. In aerospace, nothing happens fast. Everything takes so long. So we have kind of a tried and true way, which is a certified strike plate that's pickled and prepared the same as any test that would be x-rayed or any production part that you're going to weld on. And then you weld that, and then you let that sit in the environment, and you check that everything's purged out and that there's no discoloration or anything like that on either side. So it's really kind of Stone Age how we do that, but it's been, I guess, tried and true now for 40 plus years. So that's kind of what they're doing. There's no parts per million meter, I guess.
Yeah, when I was doing structural steel ironwork, we had I don't know what the technical term for it was, but it was a sniffer. And we would drop that, especially if we were doing like confined space. It would tell you your oxygen, level right around where you're working and all that. So I was just wondering if they had something in the purge tank to be like, hey, something's wrong with this argon. Like, because every once in a while you get a bad bottle of gas. I mean, you guys probably don't. You probably running like that UHP, the ultra high purity argon.
No, they got a Messer is the gas company. I don't know. We don't use like a Praxair or anything because we don't have like a manifold system that leads to a bunch of bottles. It's a giant tank that's probably 3 stories tall. And I mean, I don't even know what the amount of argon it would hold. I mean, you can't even compare it to like even a giant manifold system on a bunch of tanks. It is so huge. This truck, I guess, gets a satellite signal wherever the truck is in the world, or I guess in the US. I know that like it'll get a signal if it's in Pennsylvania that we're at a certain amount, and then it'll start heading to us to fill that tank up. So
damn.
I don't know the purity of this thing. I don't know how much it costs them to fill that up all the time, but a lot of alarms go off if it starts to get low. So because it theoretically it might cost $50,000 or something if you're in the booth and you're in that chamber welding, and then our part's done.
Has that ever happened to you?
That out. No, it's not happened. I've started to weld before the chamber was purged all the way, and now you got to take it out, cut that out. But you can't cut anywhere outside of where you're welding. So if you accidentally arc strike, just a simple arc strike outside of the allowable weld area, then you have to call engineering down, and then just to make sure that you can just put a real quick hit on there with a die grinder and get that thing smoothed out and make it look like it never happened. Just to do that outside of the weld area, you have to get approval and go through a lot of channels. If it's in the weld area and you start welding and it's not purged correctly and you do get some discoloration, you're able to take it out, clean that specific spot up thoroughly and completely, and then put it back in and continue. But that's only in the area you're welding.
It makes sense. A lot of people like to kind of brush off arc strikes, but I mean, it's a micro crack at that point. That's what a lot of people don't realize. And it'll propagate through the part, and they're like, oh, it's just an arc strike. I'll hit it with a wire brush. You'll never see it. Well, it's still there.
Well, I mean, these guys will take, that's I think where a lot of the pride comes from is we'll hear the building will shake. I mean, every so many weeks, they'll start testing. They finish building one. They'll start testing it and making runs, and the building will start rattling. I mean, these things are taking off. It's right by St. Louis Airport is where I'm working at. So that whole Boeing campus kind of surrounds St. Louis Airport. They're real proud of it. It's big, giant signs off the highway. So they test a lot right above us. We'll go outside, look up, and then, F-15 that we welded a bunch of titanium and stainless parts on will be just flying straight up and just shaking the ground. And it's definitely a moment where you take a lot of pride in what you're doing. And it's not, I took a lot of pride in all the other stuff I was doing, but I don't think that I would have ever cared if I had an arc strike outside of a weldable area and there was no process to follow to tell me not to do that, or that was acceptable or wasn't, or the process in which you get that approved to clean that off and take care of that. So it was never even something I looked at too much, but they had, for example, like one of the test pilots come and tell us what they do. They essentially take the plane to its max to see if stuff falls apart right after they get it, right after it's done. And you don't want arc strikes in there. I mean, these things will go 1,600 miles per hour, I guess, and Mach 2.5. And they'll be 20,000 feet above, a commercial flight. So they'll be like 50,000 feet or so going almost 2,000 miles per hour. You don't want arc strikes outside of where you're welding or any of this stuff. This stuff is getting beat on probably more than any other welded piece of material, I think, in use. I mean, it's not pressurized pipe is probably a close second, where it's just constantly under pressure. But I think it's comparable to like structural steel. I don't know if I'm not really familiar with it. I've been doing this now for a while. What are the arc strikes? What's kind of that stuff with your background? I mean, is it just frowned upon, but people really didn't care too much, or were they pretty on top of you guys getting off of that stuff in your industries?
Oh no, people with structural steel ironwork, like a lot of the stuff that I saw, people cut so many freaking corners. It's insane that stuff is still held together. I mean, like just bad welds, like improper rod storage, arc strikes all over the place. You look at some of the welds out there and you're like, why is this stuff still sticking together? Not the companies that I was working with. A lot of times I was the only welder till I got into like the Ironworkers Union. Then I was surrounded by other welders. We took a lot more pride with the work that we did. If there was arc strikes, you could call an engineer over, you cut it back out, you can fill that area back in, level it back off. It really depends on what it was for. I know when we were doing stuff with roller coasters, there was a 0 arc strike policy at all. I mean, they'll cut sections out and replace it.
I mean, that makes me feel marginally better about riding roller coasters, I guess.
Oh, there's so much safety built into them.
You can't help but look at every weld everywhere you go. I think since the day you start welding.
Yep.
So I'm always looking at those, and I wonder what those criteria are that they follow to put those on, or if it's I could apply and weld for a contractor and go weld that. So it's nice to hear that they're taking a look at those the way they are.
All right, we're going to go ahead and take a quick commercial break. This segment of the Arc Junkies podcast is brought to you by Everlast Welders. Are you looking for affordable, high-quality welding machines and plasma cutters? Check out my friends over at Everlast Welders. They offer machines for every skill level and budget, including the versatile Lightning MTS series. Get fast, easy shipping and a 5-year warranty on all their IGBT inverters. And listeners of the Arc Junkies podcast get a free Nova foot pedal and TIG torch upgrade with any machine purchase that comes with a stock foot pedal. Just use Arc Junkies in the comment section at checkout. Visit everlastgenerators.com today. Everlast Welders. Weld mean, weld green. Now let's get back to the show. Yeah, I know some of the roller coasters that we worked on, they were actually pressurized with nitrogen because it doesn't expand or contract due to the atmospheric temperature. So they pressurized the entire section or the entire coaster because it's all tubes and pipe and whatnot. But they pressurized that whole area with nitrogen, And so if there's ever an increase or decrease in pressure, they know that there's a crack, well, most likely a decrease in pressure, that there's a crack somewhere in that system. So it'll set off a bunch of alarms. It'll stop everything. It throws a bunch of red flags, and then people know to go out there and try. Now we're going to go through and hit it with a mag particle or dye pen. They just go through and, they'll walk the track literally inch by inch and do a bunch of NDT on there to make sure, try to locate what's causing that decrease in pressure, get that repaired, repressurize the system, and then, check it again.
Yeah, I wouldn't have. I mean, I would have thought contractors get hired out and maybe they have an in-house weld test and, because you surprised, I think, sometimes how stringent certain industries are. And then I was surprised at how lax other ones were.
Mm-hmm.
Like, for example, the HVAC company that I was working for, it's industrial HVAC units and like air rotation devices. There was no real procedure to follow to weld these lugs on the side of the unit on the base. So we weld this frame up, everything, go on Amazon buildings or local hospitals, anything. And they would weigh tons. And they would helicopter some of these things up on top of the building. It's so high, or they'd crane it. In New York, obviously, you're going to crane it up quite a few stories. And I don't know how traceable some of these lugs were. I mean, it's just maybe in the back house, after we were done with it, they started documenting stuff that we didn't know about. But yeah, I mean, it was after I left, I think I found out like maybe they should have probably called somebody like you in and really got a situation down. Like, this is what we're following. This is what we're doing. This is why. This is what you have to do to qualify and be certified to weld on any of this stuff, especially if helicopters are lifting it up. But, we just looked at a rough blueprint that a CAD guy put together, no weld symbols. The fillet gauge, what is that? It wasn't even in the shop. We just put that pig flux core weld down. It looked good. Everything looked good. And I'm positive that they were all fine and we were going above and beyond what we should have. But there was probably not the actual procedure in place to be putting those things on there.
Yeah, it baffles me how many things get welded that don't have procedures.
I've never touched a procedure in almost 10 years. I was almost 30 before I even picked up an honest to God procedure, and that was in aerospace for the first time. And it was, just so happened to be some of the most detailed procedures as I kept welding and figuring stuff out. But it's a lot of industries, they just want it welded, and I don't know if they know what they are doing wrong, to be honest, until something bad happens. And then they have to revamp and look at everything. And then they start calling CWIs and this and then that, and they're really putting the focus on it. But before that, why do we need a CW? John's been here for 15 years. He's a good welder. So, I don't know how many.
Nothing's broke. We haven't had any return parts.
Yeah, nothing's fallen out of the sky yet. That's horrifying. But that's unfortunately, I think, how a lot of people look at welding in general. It's if you don't have a passion kind of for it, like I'm really into it. I've been into it. Probably more of a pretty boy than I should have been because I was not a fan of the grinding all day. There's some shifts in welding. It's just the world that we live in. You have to cut your teeth. In welding, you'll be grinding sometimes for 2 weeks. Depends on what shop you're at.
Yep.
A job shop, you want to sit down and do real clean TIG weld, but that's a fairy tale world. So unless you're in aerospace or some kind of chemical plant or food grade stuff, you're just really not going to do that. And there'll be weeks where you're carbon arc gouging. When I was working on those barges, they ram into stuff in the Mississippi, and then you'd have to gouge out and then grab a rosebud and straighten out stuff and then gouge some more because this part's cracked, and then you keep straightening stuff. It wasn't glamorous or anything, but you just grab a bucket of stick rods with a rod oven, even within 100 miles, I doubt it. I mean, we're working right off the Mississippi. It couldn't be more moist. Everything is wet. So when I look back as I progress in welding and go, oh, all that stuff was probably wrong. I mean, that's probably not. They should have got the best rod oven that you can possibly buy with money when your rods sit right on the side of the Mississippi all day and night. They weren't even in an enclosed capsule. It was just in a bucket. And that's what we were doing. I mean,
yeah, I
until something tragic happens, they probably won't, make the calls and get stuff really going the way they need to, though.
Yeah, or until the inspector rolls up and holds them accountable. Like most of the companies I worked for, we'd open up a can of 7018s and it'd ride around in the truck for, a couple of weeks, depending on what you're doing. And it never saw a rod oven, and like, I didn't know any better. Like I knew in welding school, way back, in the mid 90s, we'd pull our rods out of a rod oven, but I was never really explained why they were in that rod oven. They're like, oh yeah, it's low hydrogen rods. Okay. That was the extent. And then you get out into the real world and they're like, nah, just, go get them out of the can there, out of the back of the work truck, and then, get you a handful, throw it in your rod pouch, go back to work. And that's kind of how we did everything. And you sit and look at, you watch some of the...
Did you question it back then?
No, because I really honestly didn't know any better. I was like, oh, okay, just grab the rods. And
I'm making sure I wasn't the only one. I didn't even question it.
No,
and I think later, I go,
industry does a poor disservice for young welders getting into it because like you kind of rely on that older generation to tell you how to do things right. It wasn't until I got into the union that I was like, why do you guys have portable rod ovens everywhere? Well, we got to that's where we keep the low hydrogen electrodes. What do you mean low hydrogen? 7018. Oh, that's supposed to go in an oven? Like, because you learned about it in school and then you don't practice it, for 10, 15 years. And then you get into a trade that actually adheres to the rules and you're like, oh shit, like I've welded several hundreds of pounds of 7018. Hopefully none of that stuff's going to crack due to, hydrogen-induced cracking. I mean, luckily, none of it was pipe or anything like that. But I mean, I've welded some pretty heavy connections with 7018 that, you just pop open the can and bring it next to you where you're working and you just weld out of it all day, and whatever you don't use goes in the back of the work truck, and then you grab that same can the next day and go out there and finish your job.
No, that was my vote. Usually it's all fine. Probably it is all going to be fine until the weld's unneeded and that thing's torn down. But the one or two handfuls of times every now and again that it's not fine and people die, I'm real aware of what's going on, or should I say not going on, when I look back at all the places I've worked and friends of mine have worked. And we did use a rod oven to warm up food. That was one place I was at. And
right.
There was put it in there at about 8, and then about 10 or 11, it'd be right where you wanted it.
Yep.
And that was the only rod oven in the whole place.
I have noticed, especially, and maybe it's different in other parts of the country, but here in Central Florida, especially now that I've opened up an accredited testing facility, a lot more companies are calling me up and they're like, hey, we need a procedure because we're out here trying to do this job and the inspector won't let us proceed until we have a procedure. Is that something you do? Yeah, I can write you a procedure. Or, hey, we need to get our guys tested because, we had one guy that's certified. Well, we got 6 guys on the job site and the inspector's only letting that one guy that's certified weld. Okay, so the inspector's doing his job. So, they'll send me 4 or 5 guys to run down there and do a test because they're already on a job where they're needed and they don't have a cert. So I see, at least within the past couple of years, there's been more of a crackdown when it comes to companies, working off welding procedures, getting procedures developed, training their welders to the procedures, getting their welders certified. So I think, things are getting better because before, welding was the wild, wild west. As long as it stuck together and held, you're good to go. But I think now they want more traceability. They want to make sure everybody's trained and certified to do the work. So it is looking a lot better from at least where I'm standing.
No, I feel like it's probably good to hear for the industry in general. And then I think it also, in a roundabout way, though this really has nothing to do with anything, just my observation over the years, you can command more money even if you're relatively new to welding. It might not be 6AL4B titanium or anything like that, aerospace, and it might not be TIG or it might not be pipeline or anything like that, where people just assume that the money's decent. But even like small job shop stuff where you can command a bit more money whenever they're required to follow certain practices. If it's just, we need somebody that can make this, hopefully it doesn't look bad, but at the very least, it needs to stick. That's, I think, whenever you get a lot of those $14 or $15 an hour jobs that I'll see. And I'll think in my head, I'm like, I don't even understand how I can go to Subway and make $18 an hour. I mean, that's crazy. I can't, who's welding for that? But as crackdowns happen more in the industry overall, I think it just benefits the quality of work that's going out, the pay, because you need, can't have somebody who's tinkering around with a 110 in their garage for a couple weekends and I'll go try to work at the shop up here. And now he's welding legitimately dangerous stuff that's out on the road or, up on a skyscraper somewhere. So more regulations, I think, in general, as far as that stuff goes, probably never hurts.
No. And I mean, having certs, I mean, there's a big debate whether, you need to be certified in this industry or not. Everybody's like, it's kind of like, whether stringers or weaves, like there's a huge debate on that. Same thing when it comes down to certs. At the end of the day, like my opinion
I know
is
that debate.
If you have welding certs, you look more appealing to an employer. You can also leverage a little bit higher pay, especially if your certs fall in line with what they're doing and they need to have their people certified. Like you're more of a sure bet than somebody that doesn't have those certs. So you can walk in there, you've demonstrated proficiency at one point in your life. You can probably do it again, because you've done that test. But I mean, it's also an added value to the employer. They're like, if we bring you in, and at the end of the day, it's the employer's responsibility to test their people. But if I was going to hire if I'm hiring one individual and I've got two to choose from, and I need some structural hands, and one of them's got a 7018 unlimited thickness cert, 3 and 4G, that's probably who I'm going to put my money on, right off the rip. And I'm probably going to pay them a little bit more because they're going to be able to pass that test.
Yeah, that's a lot. Is that some of the pushback that you've had? I feel like I've heard you mention it before. Whenever you go somewhere and you're like, well, what are you wanting me to qualify them to do exactly? I just need a certified welder. And you're like, what material are we working with?
Certified
what thickness are we doing? What are we doing with any of this stuff? Because that was probably for the better part of my welding career, kind of how I looked at it. I mean, I think I've passed a different D1 in a couple weeks, 2 different tests at school right before you leave. And even then, because they shove so much, and it's not on the instructor or the school. There's so many kids. They're trying to get you to be able to weld somewhat proficiently so that you can go make some money. And then, it's up to you to continue all that stuff. So I think a lot of us thought we were just certified in general. We didn't know, I'm a certified welder. And then like even the certifications I have now that might have taken the company as far as material costs for the titanium and stainless, and then the x-rays for the butt welds, and then all the etching, and they have to send it to a third party because obviously the company that you work for can't test it in the house and then say, this guy's good to go. Mm-hmm. All has to be documented from a NADCAP facility outside. These don't mean anything if I go and somebody asks me to flux core, 3/8 inch, whatever. I'm like, I'm a certified welder. I mean, it means nothing. And if you hand me a stick, unless it's welding, you're out of luck.
Yeah.
I'm not going to do anything decent with any stick rod anymore. It's all been TIG for a while. So these, you got to be certified, I think, and not use it as a catch-all. It has to be for what you're doing, what material. It doesn't really catch all, I think, the way that people who don't weld think it does. They just want to ask if you're certified.
It's very specific. So a lot of people think, it's very similar to like an electrician or somebody with, whatever certification that they have. You're certified to do the work without understanding. And I think a lot of schools and instructors, they either may not know or they do a disservice because they're not 100% transparent with the student population that's coming through the program. But, if I go through a school and I get 3G, 4G certified, I'm not certified, for regular A36 steel. I can't go out and weld anything from group 3 and 4 on D11. I can't go out and weld aluminum and be certified. I can't be certified on any stainless or titanium or Inconel or anything to that effect. Or, just switching processes or stepping up to a material thickness greater than what's written on my WPQR. And I think that's where a lot of people don't understand. You got to look at that welding procedure qualification record, or what everybody calls the welding cert, and say, okay, there's the range of what I'm actually, this is my field. This is where I'm allowed to play. I can weld in this position. I can weld with, these electrodes. I can weld with this process on this material type, this material thickness. Like you're kind of handcuffed to a smaller area than what most people think. They think, oh, you're certified to weld, you're AWS certified. Yeah, you can weld anything. That's not the case. Anytime I switch processes or base metal types or any of that stuff, any of the essential variables, once I start getting outside of that, I'm no longer certified. I got to retest in that. And I think that's a lot of employers don't understand that. Maybe the schools really don't understand that. I try to educate everybody that comes through the program. Anybody that's looking for a cert, I'm like, hey, I'll certify you. You'll test on this procedure. Here's the welding procedure. But this is your range. This is where you have to play in. So when I type up a WPQR and, once they pass the test and everything, I tell them, here's what you're qualified to do. Anything above this thickness or below this thickness or, whatever the case may be, whatever essential variable we're discussing, you need a different cert for that so that they understand their limitations. Because a lot of times employers out there, especially with some, kids coming right out of welding school, they're hungry. They want to do a good job. They want to make the money. They'll go over there and weld on shit that they're not qualified to weld on. And the employer may not know the difference between a good weld and a bad weld. They just know that they need to get that thing out the door. So you really have to understand your limitations and stick within those bounds. And if somebody asks you to weld something that you're not qualified or certified to do, and you're not comfortable doing it, do not do that. Because at the end of the day, it's going to fall on whoever did the work, not whoever told you to do the work. You should have known you weren't qualified to do that. So you kind of got to operate within your area of responsibility.
Yeah, that's where the traceability stuff comes in, where
it's huge.
Enough time might have passed and enough people might have been around it or touched near it that you might not even accurately be able to point at who did the weld in general by the time it fails sometimes. So yeah, everything from, and it could be the material, the heat lot number from the material. Like there's so many. Did it come from the US or did it come from outside of the States? What is the makeup of what you even welded just now? You can't trace that, let alone the wire that you used or the process that you ran it with or anything. So the traceability is huge. All that stuff's huge. I haven't even begun to think about what all you run into, just some of the stories you mentioned on the podcast, but explaining that to people, you're good at explaining it. You're good at speaking and you're really knowledgeable on the stuff. So it's probably easier, but it seems like a nightmare to have to explain probably. And somebody might not be willing to get it because they just want to get this done. They need these guys certified and they're trying not to spend an arm and a leg and they want to get this job done, or they haven't even got the job yet, but they need these to bid on it and they're trying to get you to do it before. So that's probably got to be a process. I don't know. Do you handle that well? Are people pretty good with that, even if they're on a crunch for time because they understand what's at stake and you're not about to just sign off on anything? Or do you get a little bit of pushback?
Well, sometimes I get pushback, but I don't let anybody push me into, again, I know my limitations, what I'm certified, qualified to do. I don't operate outside of that area. So when I talk to people, it works out really well for me because I've worked both sides of that coin. Like I've done the work as a welder. I've worked for several different contractors, different industries. And now I'm a certified welding inspector. I've also done welding education for a number of years. So I kind of know how to talk to my audience. So I mean, and that's what really helps is when I walk in, they don't see somebody coming in with, a button-up shirt and a pocket protector and this, that, and the other thing. I walk in with a full beard, jeans, t-shirt, tattooed up. They're like, oh, this must be the new welder. No, I'm actually here to do the inspections. So like right away, like I can speak their language. I talk to, the welders on the shop floor like a welder because I'm a welder. I talk to the business owner or the superintendent or the supervisor because I've been in that position. So I know exactly what they're looking for, and I try to over-educate them and give them all the information that they need to make a well-informed decision. Because a lot of times they'll call up and they're like, hey, I need this, that, and the other thing. And I'll tell them, like, no, I know exactly what you're wanting to accomplish, but that's not what you actually need. And I say it all the time on the podcast. People are probably sick of hearing it, but it's so common. you get companies that are like, hey, we do a lot of 1/2-inch plate. I need to get my guys certified in MIG. Okay, well, first off, what machine are you running? We got a Miller 255, or we got a Lincoln, 200 or whatever. Okay, well, that's not going to work here, bud. You're going to want to switch over to a gas shielded flux core process. We're going to maybe run some metal core. We'll get you into a different machine where you can get into a spray transfer if everything's running flat and horizontal. Like I explained to them, like, here's why you don't want that cert, because you're going to have to qualify a procedure that you're going to beat your head against the wall trying to do. Whereas I can come in and say, hey, switch your gas, switch your wire. Let's try this. Okay, now I can certify all your guys. I just saved you a ton of money. We don't have to, get a bunch of guys down here to try and, certify on a process that's prone to lack of fusion. So I get that one all the time. And once I explain to them and I can point it out and show them references, they're like, oh, okay, well, let's do it your way. Cool. Like I had one company and I kept telling them, I was like, stop sending 3/8 plates, short circuit MIG to me. It's not going to happen. These plates aren't going to pass. And so I went down to the shop and they're like, well, what do you want us to do? And I was like, switch over to gas shielded flux core. No, our guys aren't going to be able to do that. And so, like, I didn't train anybody because there's a conflict of interest. If I train somebody, I will not certify them, right? It's right there written in all the stuff that I have to follow.
It says it in I think it spells it out word for word.
Yeah, it's in, what is it? QC4, I think it's QC4 for certified welding inspectors or, training facilities. But I'll go over there and I'll show them, like, here, just watch me. I'm not going to train you. I'm not going to teach you how to do anything, but I'll, throw a spool of gas shielded flux core in there. Make sure I got the drive rolls, contact tips. Here, watch this. I pull the trigger, slow, steady, vertical weld. Boom, done. That's all you have to do. Do that 3 times, and we'll put that on a test plate, and then I'll qualify you guys. And I'm like, man, I didn't know it was going to be that easy. Yeah, like your people know how to weld. I just need to tell them, here's what I'm looking for. And they're like, oh, okay. And here's your settings. Here's a welding procedure specification. Keep your wire feed speed between this range. Keep your voltage between this range. Keep your contact tip to work distance, this far out. Pull the trigger and run it. Like, you guys know what you're looking for. You know how to read a puddle and give the weld what it's looking for. So it's easy for me to do that. And once I can go in there and show a client or a customer, like, here's how easy it is, they're all in. And when you take the time to educate your clients, there's a lot more buy-in. You kind of develop that level of trust. And that's when I start getting return phone calls. They're like, hey, we got more people, or, we got to do this, we got to do that. So a lot of them don't know because they weren't trained correctly. They don't go out for continuing education throughout the year. They learned how to weld, back, when they were 15, 16 at a vocational college, or vocational school, like most people. And then they didn't advance any of their training after that. It's all been on the job. So they could be doing something wrong for 2 decades. But they don't know until you walk in there and explain, here's why that's wrong. Here's what we're going to do. Here's how I'm going to save you money. And also in the process, we're going to get you code compliant. So just it works out better that way when you can educate the client. And that's why I think people that have welded before or, come from a welding background make better inspectors for the most part, depending on what you're doing with that, that inspection endorsement.
I feel like you might be probably, saying that nicer than you really should. I mean, because it's exactly the person that comes to mind. I mean, I don't.
But on the other side of that coin, like I know a lot of inspectors that don't have a welding background that are like really smart when it comes to welding inspection, and I've learned a ton from them. And I can honestly sit back and say, it really, at the end of the day, it really doesn't matter if you know how to weld or not, because you know what the criteria is. Like I can train my kid what the criteria is and say it either passes or it doesn't.
But then comes in where you can probably lend more of a hand on helping them get past it, where the guy that he knows exactly what it needs to be and what range it needs to fall under, but tolerance wise. But if you go, well, how he's going to say, like this NADCAP guy, he was a welder. Oh, and you could tell the second he came. And I'm like, that's rare that happens. And he said that angle on there is a little dramatic. And I just looked at it and I go, he's not wrong. I mean, I had this thing all the way up and it probably shouldn't have been that far up, but you just do it so many times, you don't really think about it. And I'm like, I really need to keep an eye on that angle and keep that torch pointed a little bit. It's just You know, it was just so slightly up, and he just noticed it. And he said, "Do this, and it'll probably come out a little smoother for you." And it just worked. Where somebody else would come by and they're just not a fan of it, what's going on, but they couldn't tell me what was causing it. So
Yep.
that's probably a benefit.
I had inspectors like that when I was in the field welding, and they're like, "Yeah, that's not going to work." Okay, well, how do I fix it? I don't know. You just need to fix it because that's not right. Well, what do you want me to do?
Yeah.
Make it right. How? I don't know. You're the welder. I'm the inspector. Figure it out. Well, shit. Now we're at a standstill. Okay, I'll call you back when I get this figured out. Now I got to go, find my supervisor or find somebody else that's, hey man, the inspector says this isn't right. How do I fix it?
That is so disheartening to fail something and you just don't quite know what you're doing.
Yep.
Wrong.
But that's how you get experience. And then you never forget. You never forget because that failure, it's like, it's right there in the back of your mind. You never forget how to fix that.
Yeah, I know I saw my boss's face whenever I finally passed the last test. The two gentlemen I work with, one's retiring in December. The other one's, I think, 59 or 60. And I think he's pretty keen on retiring the second he can, too. So we have Rex out, and I'm nervous. I'm getting shaky for when they take the test when they come in. Because, man, when you send them out and they get x-rayed and they do all that stuff, and you come in the next day, you don't know what day they're going to send back the information to your superior, but you can, every day you come in and you look at his face, if he has a guy that can weld on production stuff or not. And whenever you didn't pass and you got to go back in the booth and do some more and send those out. And exactly from 10 yards away, you turn the corner and you can see him, when you passed. It's important though. It's important to fail it. They send back the specimens. You can put a 10 power on it and look at what they were looking at and see what was failing, or I guess it's 100 power, what they use. It's important to know why you failed and get a little bit of guidance in fixing it.
Yeah, that helps out quite a bit. I mean, when you can take somebody and say, hey, look, and that was the great thing, because I was developing a couple welding procedures a couple weeks ago with one of my good buddies. And because he was able to make the weld and I could do the destructive testing right then and there, he'd look at it and say, yep, I know exactly what I need to do to fix that. Because he's a welder. He's got that experience. He knows, here's what's causing that failure. Fix that part. We ran it a couple more times. Everything passed. Everything was good. We got the procedure dialed in exactly where it needed to be. So it's repetitive. And then we were good to go from there. But like having that instant feedback and saying, okay, you got some porosity here, or, you've got, this is where you contaminated your tungsten, or, whatever. Now you know exactly what to go back and fix and avoid on the next pass.
No, that makes sense.
That's why I tell people, like, make every weld better than your last. Like, look at what you did and figure out what went right and what went wrong, and do more of what went right and less of what went wrong, and you'll be on the right path. You got to evaluate your work.
You do that regularly, and you find pride in what you're doing. Because I'm not gonna lie, there's jobs you've had, or at least I've had, where the day of the week in a specific job, and everything just kind of comes to a head at the same time, where you're like, I don't care. This thing needs to stick, and you got to get out of that pretty quick, because I think by and large what we're doing, whether it's this industry or gas or structural stuff or anything, it's pretty important. I mean, you're just a dirty welder doing some welding, but you want the morale to be up, and I think you should try to find pride in whatever you're working on, because it takes a lot of skill to do, I think, what we're doing.
Oh, for sure.
It takes a lot of skill. I mean, I'm so dumb when it comes to most other processes of welding, because I haven't been in the processes for a while, and they're always changing. And even what I'm doing now, I don't know even probably 50% of what there is to know. And by the time I get to that 50%, things will have changed to where now I'm even further back. So you're just always learning and always trying to put down something decent, I think.
Yeah. Now, when it comes to that, like, do you have to make repairs? I mean, like, what happens when you're welding out a piece of titanium and you dip your tungsten, or because, you don't have that right angle, or your face is against the glass and you can't correctly see, and you just dip it, or, you contaminate your filler? Like, what's the process to repair something like that? You take it out of the box, you grind it out with like a diamond wheel, or how's that?
Well, yeah, you have a certain amount of repairs that you can make on your own accord, and then you have to call engineering and go that route, which nobody wants, but it's important and necessary. So if you're dipping your tungsten and stuff like that, you can usually just take it out, clean that spot if it's in the weld. I have a lot of these parts get kim milled. They're trying to make them as light as possible. So an already super light titanium part that you can pick up with one hand and throw around, they want it lighter. And then they want it lighter, and then they want it lighter. So when it's as light and thin as structurally allowable, then they go a step further and they chemical mill portions of it out just to take weight. So it'll still be the part they just chemical milled a bunch of portions just to take off excess weight.
Damn.
I mistook one
grams.
of those kim milled spots. What's that?
You're talking grams at that point.
They're taking everything off.
Jeez.
It's like I said, it'll go almost 2,000 miles per hour, 20,000 feet higher than a commercial plane. And they're pretty proud of, and I work on the parts that go into things now. So by association, I'm pretty proud of. One's never been taken down. So when that F-15 is flying around, it's carrying more load as far as ammunition than any other plane. I think it's faster than any other plane that's going that can carry a sizable load like it. So they're pretty serious on weight, and they're always trying to figure out what they can machine or what they have to weld or better ways to weld it. They're even accounting for the amount of weld that you're putting on this part. So that's where it comes into the inspection, where you can't have just an obnoxious amount of weld and too much reinforcement. It's messing with the weight of everything, and you're pushing stuff away. So if I mistake, which I only did once, a kim mill area for the weld joint, because where it's kim milled, it's like a little cliff. It drops off right there, and now the part is extremely thin. I mistook that for my weld joint because it was just above it, and I just started welding it, and I just put a weld on that. It was outside of the weldable area, and you had to call. Theoretically, you could clean that up and get in more trouble than I care to figure out what it would be. But I had to call engineering, and they have to look at it, and then it goes through this giant tag process where they determine whether you can fix that or not. And then you have to carefully grind it, clean it, document everything you're doing, what happened, why it happened, and what's going on. So there's a huge process that makes the work order that follows the part the size of a Bible by the time it's done if you make a mistake, because you document every step of this mistake just like you do the normal production. But if you make a mistake in the weld area, like I blow a hole or it's only allowed to be 1/4 inch high. That's the amount of weld that's supposed to be on this thing when it's said and done. If I went over that and I'm checking it at the end and then doing the inspection and following all that, if I put the fillet gauge in and it's not coming to where I need it to, I can take that down. But it has to be in the weldable area, and you can only do that 3 times on any given part before. If you have to do it more than that, then clearly you're not doing something correct, or the part's not fixtured right. Something's happening that they want to come take a look at. So I think that's why they arbitrarily make it, 3 weld repair attempts before we got to come look. But no, there's no repair in the sense of a part comes back and you repair it after it's been in service. It's all OEM. So any of the repairs are really, kind of a user error or a fit up error. And it's pretty easy to repair because it's a really clean part still. And you can usually, get it the way you need it to. It's not been ran through the ringer like a part that'll come back out of service.
Right. So now when you said you had to grind on them, what type of wheel? Or is it like a specific wheel? I imagine you're probably not using like a regular grinding disc, right? Is it like a diamond wheel? No,
it's all carbide. It's all carbide bits.
Okay.
As far as grinding on the weld itself, it's carbide bits. In the fit up process, they'll use some different DAs with different pads of, varying coarseness and what have you, kind of fitter's preference, because they're fitting up on the fixture. These parts don't come perfect to fit up on the fixture. The fitters actually do a little bit of fabrication and grinding to get these things to fit for us as perfect as they can. So they'll use a lot more tools as far as the fitting side goes to get it ground down. But really all we're touching that thing with is a carbide bit. We'll wire brush stuff too as well.
Yeah, that makes sense. You're not leaving
God
anything
forbid
behind.
Let's say, God forbid you wire brush some 321 with some 6AL4V titanium. So you got to keep all the brushes labeled. Get in trouble with that. Can't leave any rods in the bubble. All the rods have to be identifiable. That's the standard aerospace quality stuff. Everything's traceable. The brush you're using has to be labeled. The carbide bit you're using, is that just for titanium or is that for stainless? And how do you know which one you even are supposed to use it for? Show me how you know which one it's for. So a lot of that stuff.
Oh man, I'm glad I'm not the only one. Like I'll take anytime I get a brand new stainless steel wire brush, I'll literally write stainless steel on this one, aluminum on this one, steel on this one, so I don't get them mixed up because I don't want to cross contaminate just on something as simple as the stuff that I do.
Well, I mean, it's probably a good practice to do it on that too, because who doesn't want the best weld or the best part possible? I mean, if not for aesthetics, just to look at it and say, man, that looks good. If not just for quality's sake or structural integrity, goes a long way to identify all that stuff and care, not just whatever brush is closest in your garage, grab it and start. What's a brush cost? A couple cents if you buy them in bulk, a little small wire brush. Identify all that stuff and keep everything nice and clean. It'll keep you, aerospace kind of makes you do it, but it's a practice that you can kind of take to anywhere. It'll make you more comfortable at work.
Yeah.
You won't make more mistakes. Everything is clean, labeled, identified. You breathe easier when you're welding instead of, what brush do I have in here? I didn't write what, did I use this on stainless last week? It's Monday. I don't remember what I did Friday.
Yep. Taking all that guesswork out of it.
I think I used this on stainless. And then you'll start sparking up on that. The second you weld titanium and anything is in there that isn't titanium, it'll just crack. It's just, and it won't crack until it's all, until it's cooled down or in the process. But if you make a 6-inch weld, a 12-inch weld, whatever, they're fixtured pretty well with a lot of copper. So you can make a real long run without worrying about distortion. So you might make a 12-inch run on, trying to think like a duct part for what would be a portion of the exhaust or intake. You'll make a 12-inch run. And if you, for some reason, didn't put 6AL4V rod in there, even if you use commercial pure, which in all reality is going to be fine, but somewhere along the way, engineering determined it wouldn't be. So they treat that like you used stainless. So you have to use the exact rod. Everything's got to be perfect. If you use stainless, though, then you'll get done with that 12-inch run, and the weld, it'll look off, but it didn't look off enough while you were welding it. You're like, maybe there's fog in my lens. Something's going on, but it doesn't look off enough for you to stop, but it's all the way off. And the second you take your foot off the pedal, the whole thing will just crack. You don't even have to touch it. It's something, the way that other material reacts with titanium, and I've done it just to mess around and see with scrap titanium, then you just run a nice little bead down it, a fillet, whatever, a lap joint with a stainless rod or any rod. I'll use a random rock mount, just one of the rods the maintenance guy has. I'll use mild steel rod. It'll just crack. It's the weirdest. Sure, somebody that knows metal in depth and the structural integrity and what the makeup is could explain why, but it immediately turns so brittle that you don't even have to touch it or lift the two pieces off of each other. It'll just crack and fall apart. But with the correct filler rod, it's one of the strongest materials around. So it's bizarre how that is.
Yeah, it's kind of like cast. Cast is very finicky like that. It can be. Once you take that heat away, once that puddle is no longer fluid and it solidifies, it's like snap right down the whole joint. You're like, shit. Should have preheated it.
I wish you could preheat everything, to be honest. I kind of treat Because we have to weld within the parameters for whatever specific part that we're welding, I usually go to the max just automatically. I mean, if it's in between 80 and 110 is where you're needing to be, I'll just put it at 110 and usually try to set that arc start to 110. I'm trying to get this thing hot and going immediately so I can, back off and play with it as I'm going, which I think is only a thing that I'm allowed to do because these fixtures are so, filled with copper that the whole time you're welding, it's just sucking that away. So I'm trying to get that thing hot as I can immediately and then follow along with that. Whereas I think most people, it's right off the bat, they're trying to keep the heat away. They're trying to get just enough heat to weld what they're welding and not let it get away from them. But I'm constantly fighting the parameter. I'm not allowed to go any hotter, so I can push down all I want, but I can't go past 110. And there's so much heat sink behind this thing that I'll make a long run just so that I can get this part heated up where I want it and then continue all the way around and then continue back over that initial start. But again, there's a reason for the parameters. There's a reason they're there and they've worked and stood the test of time. So that's what I follow, but there's a lot of stuff to play with. The moral of that, for the most part, is if you weld titanium, make sure you have a titanium filler material and you don't accidentally grab anything else.
Yep.
Because you're in for a bad time.
Know what you're picking up.
You're in for a horrible time.
Well, awesome, dude. Aaron, before we get out of here, why don't you tell everybody where they can find you and if you plug your socials or anything like that?
Yeah, I don't post too much on anything, but if anybody has a general question about working in aerospace, or if you live around St. Louis area and want to work in aerospace, my Instagram's AaronMP44, and then you can just find me on Facebook at Aaron Pepper, Pepper. So just out and about if you have any questions pertaining to the nonsense I spoke about today.
Well, awesome, man. I appreciate you taking the time out of your day to come out here and educate the listeners of the podcast.
No problem. Anytime. I enjoyed coming on, and I enjoy listening to as many podcasts as I can.
I appreciate that, man. All right, ladies and gents, I hope you all enjoyed the show. If you're finding these episodes beneficial to your welding journey, please leave me a review on Spotify or Apple Podcasts, and consider sharing the episodes with a friend. You can also stream episodes directly from my website, arcjunkies.com, and feel free to hit me up with any questions, comments, or concerns by sending an email to show@arcjunkies.com. I hope you all have a great rest of your week. Stay safe out there, and until next time, make every weld better than your last.